The first vulnerability that potentially exists in this code is a denial of service attack that can be established because of the conditions that exist in this code. Let us zoom and pay attention to the highlighted portion of the code, particularly the first section that says get connection, thereupon calling a function called as get connection. Here, a database connection is established to enable the lookup of the user's identity and establish a session. Note that the faults that lie here is, first of all, a global database connection is created. That's great. It's an optimization measure that all of us do. But what is a lead-on fault is we're not using a connection pool design pattern, which means connections are not released in the control block. So if an attacker just repeatedly attempts logins, connections are exhausted. And over time, that could lead to resource exhaust, which could lead to your application to fail. This is essentially called as an attacker-induced denial of service attack. So let us quickly zoom in and examine how Ocular can be used to traverse and understand this vulnerability. Firstly, I've downloaded this sample application. By the way, it's available on GitHub under the slug tar pit, which I will share after this presentation is complete. I have downloaded this application or cloned this application on my machine. The first act is I'm going to create a package. As a consequence of creating the package, it created a WAR file, which is typically deployed in a web server. Now, the next call to action is I'm going to create the graph. The graph is created using a command java to CPG, which takes as input the WAR file and produces an archived protocol-based representation of the code property graph. Now, this command causes computation of the graph, extraction of information, and connecting all the elements of your software supply chain represented in your application, which could be your open source, the servlet framework, and everything else representing the application. The graph was created in less than 3 seconds. Again, time is a function of the complexity of the application, but we have optimized very fast creation. The next step is to create the security profile, which is the up-leveled representation of information flow in the code. This command takes as input the graph and produces another representation to represent what we call as a security profile. Think of it as a fingerprint of your security posture of the application for that specific version. This again was produced in less than 19 seconds on clock. Now we have at our dispense both the graph and the security profile. So the first call of action is we enable the Ocular prompt, which is a command line interactive interface, and load the graph that we have produced. The next step is to execute another command called as load SP, which essentially loads the security profile that we've created into this namespace. Given that this is an interactive console, what we have done now is loaded both the graph representing this application and the security profile into this namespace. Now we're going to ask intelligent questions upon this in order to suss out whether this piece of code is dealing with a database connection and not a connection pool, and effectively seeding this anti-pattern leading to denial of service. So the first question that I'm asking here is CPG method full name, driver manager get connection, caller. So this particular API sequence is providing me information as to whether I'm using a GET connection in this code snippet. The next question that I'm going to ask is whether we are closing the connection, because as we examine this code, it is evident that we're not closing the connection that would lead to a denial of service. So my response is false, which clearly indicates that we are not closing the connection. Now the next follow-up question that I'm going to ask is whether we're using a connection pool, because as an architect, I have mandated that we have to use connection pools in applications, because this is an effective way to ensure that we do not exhaust resources. Again, the answer is false. So it is evident that we are opening a connection, we are not using a connection pool, and we are not closing a connection. So as a security personnel, my next call of action is to pass this feedback to the engineer who has authored this code. And given that engineers live in GitHub, I'd like to figure out a way of taking this data that I've extracted, or this intelligence that I've extracted, and communicate back with the engineers. So from my live session, I'm going to create a message to say that there is a possible denial of service vulnerability in this servlet, and given its conditions. So I'd like for the author of this code to go ahead and pay attention to it. So using very fluent API, I'm going to create an incident or issue in GitHub. So this interactive console, Ocular, has the capability of supporting higher-level APIs, meaning you can codify communication paths to GitHub, Jira, and other subsystems so that any intelligence derived is taken back to engineers to address. So given that I created the issue, I'm going to traverse back to my browser. There's 0 issues here, and note there's 1 issue here, the issue that I just created about a few seconds ago. Now this shows that I've taken interaction further to my engineers and closed this feedback loop.